So in yesterday's notes, we learned how to do something called determinants. And determinants are a single number that you get from a matrix by multiplying along its diagonals. Today, we're going to learn the application for what you do with determinants. It is something called Cramer's rule. So the first thing you want to know is that Cramer's rule is a quick way to find a solution for a system of equations by only using determinants. So that thing that we practiced with yesterday, and that a lot of people find pretty easy to do, it is a way that you can use to solve a system of equations if you don't like that Gaussian elimination process. So here's how you use Cramer's rule. The very first thing that you do is if they give you a system of equations, like what's over here, x minus 3z equals -2, 3x plus y minus 2z equals 5, 2x plus 2y plus z equals 4. What I want you to do, instead of making one augmented matrix, which is what Gaussian elimination does, we're going to make two separate matrices. One just for the coefficients. Those are the numbers that come in front of your letters, x, y, and z. So the numbers from the left-hand side of the equal signs. And then we're going to make a separate matrix called B for just the constants. So in this particular problem, that'd be the 2, the 5, the -2, the 5, and the 4. So this is what it looks like. Matrix A, which is just going to be the coefficients from in front of x, which is going to be 1, 3, 2 down the first column, 0, 1, 2 down the middle column for the y's, -3, -2, 1 down the last column for the z's. So this is just the coefficients. And then we make a completely separate matrix for just the constants, -2, 5, 4. We put those in their own matrix. So instead of all together in one, Cramer's rule splits us up into two matrices, matrix A and matrix B. Now that you've made those two matrices, matrix A and matrix B, the very first thing that you're going to want to do is find the determinant for matrix A. So remember, with this being a 3 by 3 matrix, your best way of actually completing all 6 of the diagonals that are required for a 3 by 3 matrix is to copy the first 2 columns of your matrix next to it so that you can finish all 6 of your diagonals. So we have 1 times 1 times 1, which is 1. We have 0 times -2 times 2, which is 0. We have -3 times 3 times 2, which is going to be the -18. Remember, all of the products going this way, we just leave it alone. Whatever it is, we don't change its sign. If it's positive, we leave it positive. If it's negative, we leave it negative. Now, for the 3 diagonals that are coming back the wrong way, so this would be 2 times 1 times -3, which is -6. We subtract that. So that's actually -6. And this one's a -4, but we're subtracting it, so -4. And this one's a 0, so -0. When you put all of this together, the determinant for your coefficient matrix is -7. Now, here's what you do with Cramer's rule. You're going to make, okay, so you take the determinant of matrix A. Now you're going to make 3 new matrices. These new matrices are called A1, A2, and A3. And the way that you make these new matrices is by substituting matrix B, so this column of numbers, -2, 5, 4, into different columns of matrix A. So you only make a replacement in one of the columns. The little number subscript next to the capital A tells you which column's being replaced. So for A1, we're using the -2, 5, 4 in the first column, but columns 2 and 3 are the same as the original. In matrix A2, it is the second column that's being replaced with the -2, 5, 4. Well, columns 1 and 3 are the same as the original. And for matrix A3, you can see that it is the last column, -2, 5, 4, is being replaced in column 3, but columns 1 and 2 are the same as the original. Now, once you make these 3 new matrices, matrix A1, A2, and A3, you're going to take the determinant of each one of these new matrices. So you can see I've already done that work here. You can see I copied the first 2 columns next to the matrix, 3 diagonals going this way, 3 diagonals coming back the other way. The determinant of matrix A1 was -28. The determinant of matrix A2 turns out to be 21. And the determinant for matrix A3 turns out to be -14. So we don't have our answers quite yet, but we're ready to find our answers. So the last step in this Cramer's rule process is you have your original coefficient matrix that we called A, and we have its determinant. And then we have those three new matrices we called A1, A2, and A3, and we found their determinants as well. To find your answers, all you have to do is to divide the determinants of the new matrices, A1, A2, and A3, by the determinant of the original coefficient matrix. That was just the plain old A. And the cool thing here is the answer, the letter that you're going to find, like for example, X, is going to be found by dividing the determinant for A1 by the determinant of A. So the letter that you're trying to find is in the column that we replaced. So in A1, we replaced the first column. That means it's going to help us find the first letter. In column 2 was the letter Y. And so when we replaced column 2 to make matrix A2, that's going to help us find the answer for Y. And A3 helps us find the answer for Z. Divide your new matrices determinant. So A1's determinant was negative 28 by the original coefficient matrix A. Its determinant was negative 7. So that means the answer for X is 4. And for Y, you're going to get 21 divided by negative 7, which is negative 3. And for Z, you're going to get negative 14 divided by negative 7, which is 2. Now, you can still check these answers the same way we check answers for any other type of problem. If you're not sure if these are the correct answers for your problem, you can just plug them into the original equations and make sure they work. Remember, there would need to be 3 checks because there were 3 original equations. So a lot of people find the Cramer's rule to be a lot easier to do than Gaussian elimination. Let's try one more example of this. So here in example 2, we have 3 equations. 1x plus 1y plus 1z equals 6. 2x minus y plus z equals 3. 3x, no y's, minus z equals 0. So the first thing you're going to want to do if you're planning on using Cramer's rule is you're going to want to separate the coefficients from the constants. So the coefficients here for the first column are going to be 1, 2, 3. The coefficients for the second column are going to be 1, negative 1, 0. And the coefficients for the third column are going to be 1, 1, negative 1. So you can see I made my coefficient matrix right here. We call that matrix A. And the constants, which are these numbers on the other side of the equal sign, 6, 3, 0, they go in their own matrix. We call that matrix B. First thing you're going to want to do is find the determinant of matrix A, which is going to be 1, 3, 0. This was going to be negative 3, but it's going the wrong way, so we subtract negative 3. That's kind of like adding. This is going to be 0, so we're subtracting nothing there. And then we have negative 2, but it's going the wrong way, so we're subtracting. The determinant for matrix A in this particular problem is 9. So that's the first part of the problem. We come up with the determinant for the original coefficient matrix. Now, we are going to make 3 new matrices by substituting in these numbers from matrix B into different columns in your coefficient matrix A. When you swap out the first column, you're making a matrix we call A1. You can see 6, 3, 0 are now sitting in the first column, but the rest of the matrix is the same as it originally was. And then A2, we swap out the second column with 6, 3, 0. Here you can see it right here, 6, 3, 0. Well, column 1 and 3 are the same as the original. And matrix A3 swaps out the third column with 6, 3, 0, and the rest of the matrix stays the same as the original. So only one column is being replaced when you make these new matrices. You will need to find the determinant of these new matrices as well. So when I did all the math here, the 3 diagonals going one way and the 3 diagonals coming back the other, matrix A1 had a determinant of 9, matrix A2 had a determinant of 18, matrix A3 had a determinant of 27. Now these aren't your answers yet, but all you have to do to get your final answers is divide the determinant of the new matrix, in this case A1, divided by the original matrix A. 9 divided by 9 tells me the answer is 1, and that's for whatever letter was in the first column, which in this case was X's. When you're using matrix A2, which had a determinant of 18, divided by the original coefficient matrix, which was 9, that tells you the answer is 2 for whatever letter was in the second column, which was Y. And A3 divided by the original is going to be 27 divided by 9, and that's for whatever letter was in the third column, in this case Z. So your answer is X, Y, Z for what time it is. You are now ready to give the homework for tonight a try. Please use Cramer's rule so that you can practice this process and see if you like it better than Gaussian elimination. I think you might.